The AH-1G and the UH-1C don't have identical rotors. Even casual observation will verify that fact. But they are interchangeable. On the Huey C model, there is a stabilizer bar which is plainly visible, and there is none on the Huey Cobra. And that is the single difference between the two systems, the method of stabilization. Let's look first at the UH-1C and how the stabilizer bar works. The open end of the pitch horns faces upward on the UH-1C, and the pitch change tube is attached to the stabilizer bar. This bar has weights which are rotated about the axis of the rotor, thus creating mechanical forces which can be used for stabilization. So the UH-1C has a mechanical system of stabilization. The AH-1G has no stabilizer bar because it has an electronic stability augmentation system. The mechanical components have been replaced by the SAS system, which feeds directly into the control system the input required to produce airframe damping. Since the Huey Cobra was designed specifically as an attack helicopter, every effort was made to make the ship as immune as possible to changes in attitude produced by wind gusts or weapon recoil. Since the pitch horn and mast are the only parts which are different, the two rotor systems are interchangeable. And DS and GS maintenance is now permitted to change pitch horns in order to convert components of one rotor system to another. The biggest aspect of maintenance on the rotor system is the inspection of the blades. There are two primary types of damage to look for: nicks, scratches, dents, holes, and voids. A void is defined as any unbonded area which is supposed to be bonded. Like other areas of the aircraft, in blade inspection, one of the most important parts of your job will be in knowing what blades you can repair and what blades you should replace. Extremely detailed instructions are contained in your TM 221-20. This book, kept up to date by including the periodic revisions, is your Bible for maintaining the rotor system. The entire blade assembly is usually removed if blade replacement is indicated, or when making the required 200 or 600-hour inspection of the rotor hub as detailed in your -20. The main rotor hub should be supported on a stand, and each blade supported so that the leading edge is straight. First, detach the drag brace from the blade by removing the nut, washer, bolt, and shims. Save the shims for use in reassembly. Do not change the adjustment on the drag brace. Remove the locking screw from the nut which holds the blade retaining bolt. You have a wrench which fits this nut. With nut and washers removed, the blade retaining bolt can now be removed. Should binding occur, merely raise and lower the tip of the rotor blade slowly. By keeping pressure on the bolt, a point will be found where the bolt withdraws easily. The blade retaining bolt is color-coded for reinstallation in the same location. One important maintenance assembly is the main rotor hub. The 200 or 600-hour inspection detailed in your -20 will require this effort. Since the smoothness of rotor action will depend to a large extent on how carefully the adjustments in this area are made, care should be taken to follow handbook instructions. Some of you who are familiar with the earlier models of the 540 rotor system on the UH-1C may observe another detail which is present on the AH-1G rotor system. It is the sand deflector which has been added to all 540 rotor systems. It was found that when the UH-1C was operated in sandy environments, the shovel action of the main rotor grips would collect sand in the grip area against the outboard grip bearing seal. Improper seal gap or seal deterioration would allow sand to bypass the seal and enter the Teflon bearing area. The addition of the sand deflector coupled with the new seal and radius ring has been an effective cure. The inspection time for this unit has increased from 200 to 600 hours. To disassemble the hub, the pitch horn may be detached by removal of 3 retaining bolts. It helps on reassembly if the top surface of the inboard bearing housing is indexed with a small spot of quick-drying paint. Remove housing bolts from inboard end of grip. Index the grip retaining nut to grip. Remove lock nut and clamp. Then remove the nut, counting the number of turns required. If grip spacing tool is not available, record the number of turns for reference at time of reassembly. Remove the grip, using care not to damage the threads of the outboard strap fitting. Loosen 2 nuts on the extension bolts. Remove the leading edge side bolt and swing grip and extension forward on the trailing edge bolt. Remove the housing from the inboard end of the grip. Inspection of the Teflon bearings should now follow. It is important to learn what is acceptable bearing wear and what wear requires bearing replacement. There are 6 photos in your Dash 35 which show various types of bearing wear with both acceptable and unacceptable wear patterns. Study them carefully and use them as standards for comparison with bearings you remove on the flight line. The whole subject of inspection of rotor components requires a degree of detail which we can't go into in this film. There is specific, detailed information on each item in the Dash 35. Perspective drawings indicate what tolerances are allowed on the various mating surfaces. Also, damage limits on main rotor hub and blade grips. Again, following the steps outlined in the handbook will get you through the whole procedure, and you will end up with a smooth running rotor system. One small but important detail during reassembly is the adjustment of outboard grip bearing seals. AH-1G main rotor heads incorporate a new type radius ring employing a bonded plastic shield. When adjusting this shielded ring, the gap should be set from 0 thousandths to 40 thousandths. If replacement of the ring with shielded type is not possible, the older unshielded ring may be used. Gap for the unshielded ring should be set at 30 thousandths, with the tolerance being from 30 thousandths to 70 thousandths. When the older unshielded ring is used, the inspection interval is also reduced to 200 hours. Since all the rotating components of the rotor system are subjected to constant vibration, the tightness of the bolts which hold the components in place is of extreme importance. There are 27 fastening points and 14 different torque values. You may remember some of them, but it's doubtful that you will learn them all. The best bet is to refer to the figure in Chapter 1 of the Dash 20. All the values and locations are clearly indicated. Many men make a copy and keep it handy for reference on the flight line. Of course, all blades must be tracked after every installation. And this is a good point to go back to the Dash 20 and see the new type of troubleshooting table which has been provided. In clear step-by-step procedures, the entire tracking operation is detailed. And after each step, there are choices to be made depending upon how the test worked. It has been proven in actual demonstrations that even an untrained mechanic can successfully track the blades of a Huey Cobra just by following the steps outlined in this troubleshooting table. The AH-1G has pioneered in the use of tables such as this, and you will begin to see them appear in Army handbooks on other UH-1 aircraft. Of course, to paraphrase the old song, it takes two to trek, the mechanic and the pilot, since the final determination of what vibration may be present has to be made in the air. And your unit's test pilot has been specially trained to work with maintenance personnel in detecting and eliminating rotor and pylon vibration. This additional pilot training is indicative of the increasing emphasis the Army places on maintenance. The problem of keeping aircraft flying is the concern of everyone. As aircraft become more sophisticated, your job becomes more demanding and also more important.